Like you said, my name is James Dowell, and the research paper that I read dealt with the tensile and fatigue behavior of layered ABS. They were looking at components made with the FDM process. Their key question was to determine if raster orientation had a large effect or significant effect on fatigue performance of ABS components fabricated with fused deposition modeling. They made four different raster orientations. Raster orientation is the direction the fibers are deposited on each layer of the ABS components through FDM process. They used ABS P400 for their material, and they also fabricated injection molded parts using the same material as kind of a control specimen to see what kind of fatigue and tensile strength an injection molded part had in comparison to the four raster orientations they did tests on. The process conditions examined was ultimate tensile strength and tension fatigue strength, and they used a Stratasys Vantage 1 FDM machine, an injection molding machine, an Instron tensile testing machine, and they used a scanning electron microscope to take images of the yielding surfaces for the test specimen. The first test, they looked at determining the ultimate tensile strength of each of the four raster orientations, and they determined that the longitudinal raster orientation had the best overall ultimate tensile strength. And as they determined each ultimate tensile strength, they used those during the fatigue testing, and they used 90%, 60%, 50%, and 40% of the ultimate tensile strength for each raster orientation during the fatigue testing. And for the fatigue testing, they determined that the default raster orientation, which is the plus or minus perpendicular raster of 45 degrees, had the best fatigue life, with the transverse at 90 degrees and the longitudinal being the worst. And they determined that the yielding that occurred during those fatigue cycle tests were delamination between the layers as opposed to the actual ABS fibers yielding under the load. And they plotted the typical fatigue life SN curve, showing that 24,000 cycles was the best that they got from the default case. And the key conclusions from the research paper is that processing direction does have a significant effect on the tensile fatigue and ultimate tensile strength of FDM ABS components. Crack propagation is a result of the weak interraster bonding in the 45 and the transverse rasters. The longitudinal rasters had the highest tensile strength, and the plus or minus 45 rasters had the longest tensile fatigue life. And my personal critique on this article was that it seemed like the experiments were very well thought out, and all the analysis was very on point. And one thing I noticed that they didn't talk about was if there was any heat generated during the fatigue test. So if there was localized heating, maybe that would kind of skew the fatigue results if there was heating in the areas where the parts yielded.